Welcome everybody to our session named Measuring the Digital Economy. Today there are two presenters in the current session. Our presenters will have 20 minutes each to present their work with 10 minutes for Q&A after each talk. So if you have a question, please use the Q&A facility at the bottom of your screen to submit your question, and we will answer them at the end of every presentation. If you are invited to ask a question, we will enable you to unmute your microphone. Please introduce yourself by stating your name and affiliation. And please note that this session will be recorded. Our first presenter is Francesco Venturini from University of Perugia. So Francesco, please go ahead.
Thank you, Oleski. Good afternoon to everyone. I'm going to share the screen. Let me see whether you can see well. No, wait. Oleski, I think that...
Yeah, we see your screen now.
You can see my screen?
Yeah, so we can start presenting.
Okay, thank you. Sorry, but Okay, thank you. I'm pretty happy to present the paper at the ESCoE conference. This is not a new paper, but I mean, one of the first time that we present it is a joint paper with Ioana Igna of Lund University. Well, this paper is a contribution, a little contribution to the literature on the fourth industrial revolution and on how the new technological paradigm is been shaping our economy and our society. In this literature, basically, the key attention is paid to automation, robotization for their influential, very important labor market effect of associated with the diffusion of this new technology. However, AI, artificial intelligence is considered a true driver of the fourth industrial revolution. Why? Because in essence, it does allow to expand the set of manual routine tasks that a machine can implement, but above all, it can allow machine to implement cognitive tasks. So this is the first key characteristic which make AI a potential driver of the fourth industrial revolution. And AI is considered a potential general purpose technology. Basically, it rests upon on quite different pieces of technological knowledge. Basically, what we know about the economic characteristic of AI. In essence, we don't know very much so far because we are just at the beginning of the diffusion of this new technology. There are some descriptive evidence showing that companies innovating in the field of AI are mainly companies earlier engaged in innovation ICT sector. So big companies, big tech companies, big global multinational enterprise, which do not collaborate very much to each other in developing this new technology. More or less, 75% of the patents in the AI field are accounted by these big tech companies. There are some early bird evidence concerning the economic impact of AI, and at least for the US, we have evidence that AI innovating firms are much more productive than non-AI innovating firms. However, when we look at AI investment, there is no significant productivity differentials among US companies, but AI investing firms used to grow faster than the other companies. So there are also some papers specifically focused on the effect of the AI diffusion on the labor market, on the labor demand. And we see that, there is some indication that AI may affect high skill labor demand and overall the skill requirement of the new job which are intensive of digital technologies. The open question, the highly debated question in this literature is, first of all, if AI is a revolutionary technology, so allowing to create new productive tasks, or as some skeptics argues, whether AI is an evolutionary technology, which means that AI allowed to implement in any way all tasks. So Another strictly related to this question is whether AI is a pretty new technology or a follow-up, and strictly related to this relevant issue is it's quite unknown which characteristic drives the innovation process of AI innovative firms. And so this is not a trivial issue, because we know that the AI industry is highly concentrated at the worldwide level in few hands, the big tech companies, superstar companies, software house company, and basically, and basically the development of the AI market is extremely important for the functioning of all the digital economy. So not only for for all the sector which are going to use AI technologies, and basically the evolution of the sector is really relevant for the development of the fourth industrial revolution itself. Understanding which factor drive the basically the innovation performance of AI companies is crucial to understand, to foresee the evolution of this sector. And this is an important, is very important also for understanding the change of our society and our, not only the whole economy, but our society in the next year and decades. So what we do in this paper? In this paper, we seek to open the black box of the innovation activities of AI innovative firms in Europe. And we specifically want to understand if company inventing AI, so the patent productivity of AI innovating company is related to their previous research in ICT and is related to other important technological characteristics. So if there are some dynamic returns, or it depends on the company technological specialization, or company may exploit some knowledge spillover. To address this issue, we build an original dataset with which we map all AI in ICT patents applied to the European Patent Office between 1995 and 2006. And basically we collect a dataset of around 300,000 patents, of which 4,000 are AI patents, which have been applied by only 700 holders. In order to investigate the driver of patent productivity in AI, we basically restrict our attention on a sample of 400 companies, for which we have quite rich information, not only on the company technological characteristics, but also on the company technological characteristics and structural characteristics. So, and for this, our regression analysis is based on an sample of 400 companies. So just a little preview of our result. So basically, we find evidence that AI companies self-selected among the most prolific ICT innovators. So the top ICT applicant at a given point in a given time decided to switch it, to move to innovate in the field of AI. And this company can exploit strong dynamic returns. So their patent productivity is highly influenced by their previous innovation activities in the field of AI, of course, and ICT. However, the innovation rate is lower. So we find a lower patent productivity for AI company with a mature and narrow technological knowledge. In the sense, companies starting inventing early in AI are less likely to invent more recently, because their technological knowledge is likely to have become obsolete. We have also find little evidence. We find evidence of a knowledge spillover. So AI patentees are able to exploit knowledge spillover from surrounding company inventing in the ICT field. So this indication of some complementarities, but as I'll show, this effect is confined to a very selected group of top applicants. more generally, what we can say is that with the uptake of the AI economy, let's say from the late 20s, so from 2009 and so on, so there is an indication that the inventive success of AI company is extremely more dependent on the company internal knowledge, while the role of spillover is less relevant. So how we study this? All this, basically, we estimate the dynamic knowledge production function that we borrow from HiHiao in 2007, where basically the AI patents are assumed to depend on human capital endowed, allocated to AI innovation. And we account also for the duration effect of R&D in the sense that the wider the number of product varieties developed by a company, the lower is the returns of R&D. So our key explanatory variable are basically bar A, which is represent the pool of internal knowledge. So is a stock of knowledge developed in the past by the company, and in this respect, phi would identify the within company intertemporal knowledge spillover. So if phi is positive, means that the company inventing the past in AI field or relevant technological field are more likely to invent now in the future. So and the closer to one is this basically this parameter. So the more persistent the process of the more persistent is the process, the inventive productivity of AI innovators. As capture the pool of external knowledge, which is relevant to innovate in the AI fields. And basically, we assume that the pool of internal external knowledge, which is relevant, is the previous amount of knowledge accumulated by the company in the AI field itself and in the ICT field. So we estimate this knowledge production function in a panel setting. Basically, we estimate this as a count data regression using a count data regression. Sorry, using a negative binomial regression using pre-sample mean to account for company fixed effect. So the pool of internal knowledge is approximated by the stock of AI patents. So the stock of patents applied in the past by the company, and in turn we consider the stock of ICT patents applied in the past by the company. And basically, knowledge, our measure of knowledge spillover is an inverse distance weight of the patents, AI patent stock, ICT patent stock owned by surrounding companies. So for each company, we compute the geographical distance between the donor and the recipient company. So as a measure of human capital, we consider the number of inventors involved in each application, while company size is company size approximated by the employment, and in turn we consider some include some other characteristic of the company technological endowments. So a dummy which is the high maturity, so company which applied as first AI patents in the sample, the number of patents obtained in collaboration, and an Earfindal index of technological specialization that we build looking at the IPC classes of the company patents. So, basically, we build our data set from the OECD EPO Regapat database, and we collect data on AI in ICT patents from 1995 to 2016. AI patents have been identified using the classification proposed by European Patent Office in 2017, which is based on basically CPC classes, so the patent categories of attached to each patents, while ICT patents have been identified with the J-tax taxonomy developed by Maria Grazia Switcherini to OECD. At the end, our regression analysis is performed on a sample of 400 companies, for which we have, I said, enough information on the company technological characteristic and other and information on other company dimensions. So yes, quite late. So first of all, we map the AI patents in across European regions, and we compare them with the ICT patents. What we see is that there is a large overlapping between areas, because we said, as we show, company inventing ICT are the first, first mover, so the first kind of company that shift and move to inventing in AI field. However, so the AI patents are still highly concentrated in Europe compared to ICT, because we are just at the upswing, so the early stage of AI diffusion, while ICT is just more mature. So if we collect our firms across countries, so we see that Germany is the leading, so the leading country, and the German technological leadership in AI. So in this early stage of the technology diffusion is much more pronounced than what we see for ICT. An important, so we identify at the beginning 700 AI applicants. And
5 minutes left, Francesca.
Thank you. I'm fine. Okay. So what we AI we find 700 applicants, of which 500 are also ICT applicants. And what we see is that if we look at ICT applicants, those have applying also AI patents are highly much productive than basically non-AI applicants. And this can be also seen from this graph, where we see that ICT this is the total amount of ICT patents applied for the group of AI patent holder, while this group of company represent the bulk of ICT patents. So company which hold the bulk of ICT patents Europe are the only one, the main one, which also start innovating in the AI fields. So moving to the estimation, so our baseline estimation, we estimate the model, the knowledge production function into time horizon. For the long time horizon, what we see is that our data indicate that there are strong dynamic returns, in the sense that in knowledge production function, in the sense if you are a company that have already invested in AI, have innovated in AI in the past, you have had 0.7 higher probability to innovate now. So we find higher patent productivity for those companies that have already invented in the past in this field, in the AI field itself, and in the ICT field. When we look at a long time period, basically we have evidence of an influential role, significant and positive role of the IT inventing team. However, this effect disappears when we focus on the last period of time, so which is basically the uptake, the takeoff of the economy. This kind of finding also hold for the degree of technological specialization, in the sense that if over the long time horizon, we find that company narrow technological competencies basically innovate less, which means that company we have a more diversified technological knowledge are more capable to exploit the highly differentiated nature of technological knowledge which is behind AI. But this effect seems to be less important in the last period of time. Consistently with the idea that the latest wave of AI innovation make the previous high rated knowledge obsolete, we see that high mature company used to innovate less. We find evidence of, as said, of positive knowledge spillover from company inventing in ICT two companies inventing in AI. And this effect seems to be quite robust over time. The key result of the paper is about the marginal effect, how basically the impact, so how the intertemporal knowledge spillover change along the distribution of the AI or ICT pattern stock. In essence, this we have seen. Okay, we have seen that the estimated average marginal effect is 0.7, 0.6 for the AI pattern stock, which is a marginal effect. So it is an additional probability that you get if you already invented in the past in AI or in ICT. However, this effect is not flat. So I mean, change along the distribution of AI. And basically, this effect is strongly concentrated in the top applicant. So basically, top applicants seem to be able to gain a cumulative advantage in the inventing productivity compared to company with a lower past innovation activity in the field. Conversely, which imply that you are likely to so there is a high persistent, strong dynamic returns in the knowledge production function of AI, especially if you especially for top applicant. This effect is less is not the marginal effect of the earlier stock of ICT patents at the company level is more uniform along the distribution. So this is confirmed when we assess our estimation, the robustness of estimation of sample composition issues, and when we remove some sample of companies at a time, we see that this exponential effect of earlier patent activities is mainly confined to the group of top 10 applicants. Okay, so I'm going to conclude. So basically, our paper has shown that AI innovation activity, so that European company is quite active in AI innovation. However, there is indication that AI innovation is characterized by a strongly cumulative process. So, and which implies that first mover widen their gap, they lead compared to the late mover. And this is very important for the evolution of the AI industry at worldwide level, because it means that the top applicants are likely, which are the superstar firm, are likely to self-enforce their position and to dominate the market in the coming years. So that's all.
Thank you so much, Francesca. So we are now open for questions from audience. You can submit it in Q&A section. So we're waiting for questions. And while we are waiting, I have my first question. Yes. So Francesca, you said that innovation in IT companies hugely depends on internal company knowledge more and more. So yes. My question is, how do you define internal company knowledge and where it's stored? So definitely, as you say, it's stored in patents. So what other kind of storage options for internal company knowledge?
I mean, well, basically, yes, I capture. I reply now, or you wanna? Okay. Or you want to collect more question?
Maybe we'll go question by question.
Okay, good. So yes, we capture the stock. We measure the internal knowledge as the stock of patents applied by the company in these fields in year before, so in the previous years, basically. And we also basically internal technological knowledge. Maybe so we do not have data for instance on the AI jobs hired, the AI workers hired by the company. So the other option would be that one, to properly measure the stock on knowledge, so the stock on knowledge related to their field at company level. So we basically use the cumulative value of the patents applied for by the company in the previous year.
Thank you, Francesca. So we don't have other questions from anybody till now. So maybe I'll go with my additional questions that I had for you. So at the beginning of presentation, you mentioned that obviously AI is GPT technology, which I definitely agree with, and it's changing the way we are working because it's able to automate cognitive tasks, which is definitely new for AI. So what do you think, to which extent does the future of work can be automated? So what kind of task do you think will still be a prerogative for humans, and which tasks would be lost?
Okay, this is very okay. It's a very good question. I think this is the key question. I mean, this literature. I mean, there are some papers seeking to understand which skills are more likely to be affected by the new technologies. But this new technology, I mean, is not easy. For what I know, is not. I mean, is not easy to predict at the moment. There are some work for the US, especially by Babina and Ali and Michael Webb, that look at the change in the change in the demand for a specific group of high skill workers, because the idea is that AI should replace some jobs intensive cognitive tasks like visual. I mean. Some surgeon activities and so on. So I think that this is the hot topic of the incoming year.
Thank you so much, Francesca. So I think that's all questions for now. Maybe we would wait for some other questions. So maybe we can proceed to the next part of today's session. So I will present next. So again, welcome everyone, and I'm really glad to be able to present the results of our work in progress. So the topic is COVID resilience and digital readiness, and analysis using online company data. So I want to start with the definition of resilience. So resilience is from Latin, to bounce back. So in our context, we use this word to identify companies that are able to adapt or overcome COVID-induced challenges. Our study tries to approach this question whether the resilience of company depends on its preceding innovation and hiring patterns as well. In narrow scope, as currently measured, we try to assess whether the fact that companies send some positive or negative signals to the market depend on its digital hiring intensity and pre-crisis, pre-COVID innovation. So our presentation proceeds as follows. We would talk about how the firms responded to COVID restrictions and market failures in our introductory slide. The study setup will show which factors in the literature determine a resilience of company and our main data sources. Methodological section will continue with ways how we extracted useful information from our data. In preliminary findings section, I will talk about initial results and trends for innovators that we observed for the last year during the COVID lockdowns. And lastly, I need to emphasize that the current study is majorly in progress. So today I would mainly concentrate on measurement side of our work and approaches we have taken to get the data we are interested in, and not so much on results because we are still approaching full analysis and modeling. Right. In general, government restrictions imposed different reactions from firms. One cohort of companies was urged to take some extraordinary and really fundamental steps to sustain their revenue flows. They were urged to introduce new business models, establish online delivery options, roll out new products or services. I wanted to throw out just a few examples to highlight the case. For example, one of UK startups that I closely know that was concentrated on business-to-business grocery deliveries to local restaurants had redeveloped their whole business model in 1 month and developed a new online platform targeted towards home delivery of groceries through online process. They coordinated with government to deliver goods to unprotected households and really re-establish their business. Another machinery company that was doing some metal work started to do touchless hand sanitizing machines in a matter of several weeks. A lot of local restaurants, as you know, engaged with delivery services or reoriented to luxurious grocery shops. On the other hand, a lot of companies went on pause, introduced some salary cuts, sent their employees on furlough, or went out of the business at all. This includes a lot of non-essential businesses such as cinemas, retailers, marketing agencies, startups, and many others. Some of them also went out from the market heroically. For example, Costa Coffee put all of its recipes online while pausing their business. Another chain of restaurants started really a huge crowdsourcing campaign to gather funds for free meals to unprotected households. And there are many other cases how a company tried to survive the crisis. So the one thing that was clear is that IT-related industries survived the first wave really better due to their ability to shift to remote style of work, ability to utilize innovative technologies that had driven their agility and ability for fast changes. As a result, they were less inclined for closures and had better survival rates. I could refer to INS big survey for this result. However, it's really known that innovation and R&D take significant amount of time to lead to some tangible results. And there is a very high failure rate among innovative enterprises, really around 90%. So if some companies may have been successful in acting in act or die so-called manner, it becomes unclear what it takes to survive at the end of the day and how UK market reacted to this pandemic overall. I should also emphasize that our study is based on purely online generated datasets. The use of online data has dramatically increased in COVID period, and ability to gather timely data really helps us to start current study today and deliver some timely insights. So various researchers point out that obviously financial background of companies matter, and financially capable firms are able to innovate more and insulate against crisis. Joseph and others suggested that tightening of credit constraints allowed some firms to have a strategic advantage over financially constrained rivals. Size of the firm has also a different effect. In some cases, small size of company allows it to move fast and to innovate quick, but larger firms may perform more substantial innovation, whereas small firms are able to do just result-oriented quick innovation. So pre-crisis technological readiness is also a very important factor. For some companies that were almost ready to introduce a few adjustments, it was really easy to cope with crisis, whereas some others had to engage in really rapid innovation in so-called rapid innovation in order to survive or save their market share. What is important is that several UK-based studies suggest that innovation is procyclical in the UK, meaning the innovation is less intense in periods of crisis and in periods when firms are constrained in liquidity. With that said, modern IT technologies, such as, for example, cloud technologies and many others, facilitate rapid transformation, enable companies to make better use of their data and react faster to changing customer behavioral patterns and changing economic situations. We can see results how this modern cloud technologies helped NHS through a lot of studies showcasing how they were able to quickly utilize technology in order to quickly understand the data. Obviously, as all of the ICT technologies are skill biased, it's evident that one of the drivers for innovation should be foreign labor capital. So we account for that, but unfortunately we are restricted of accounting for some of the factors like managerial practices inside a firm because of the lack of the data. So our study is based on 4 data sources. First source is our measure of companies' resilience. It's based on web scraping of around 130,000 companies' websites. I will tell methodological details a bit later. The second data source is cloud indicator. We built this indicator using also companies' websites, but another aspect, it's domain name service metadata. I will talk more about it also in the next slide. Third data source is tech hiring indicator, which is constructed using skills determining job content from Burning Glass Technologies online job postings data. And our financial background is gathered from FAME dataset. So I'll start with the financial dataset. So financial analysis made easier FAME dataset derives information from scraping companies' reports. We use a subset of firms that have a website, and such limitation can potentially lead to some sampling bias, but there are a lot of motivations for companies to pursue online presence. Some of them are customer experience, company image, shaped through online content, and security of their brand. Companies provide timely updates about their business for such reasons. They introduce new products or services on their websites, and they introduce some news and so on. The supply of websites, the content supply trend, as I call it, is really backed by the content demand trend by online users. So ONS suggests a stable increase in internet usage patterns around households. And I think at present, the percentage is around 90 or more percent of household users who use internet currently. So, and from the size of business, it's about 85% of businesses with 10 plus employees that have a website as for today in the UK. According to Glass AI research, there are several industries such as health, fitness, leisure, tourism that are overrepresented on the internet. And other sectors like real estate, construction, and consulting are underrepresented. So as I mentioned, our subset of data contains 130,000 firms, starting from 2008 and ongoing till now. So it's totaling to 1.5 million of company years observations. So now I would want to talk about our main indicator of interest that we constructed. This is a resilience indicator. As I mentioned previously, our resilience indicator is constructed from web scraped content of the main page of companies' website. And we use web scraping spiders built with Python that collects main page from website. We transform collected information, which originally is stored in HTML. So we get rid of HTML text, do some pre-cleaning in order to arrive at clean human readable text of the website. And after that, we use automated content analysis methodology. So I would quickly explain the main steps that this methodology takes. So the first initial steps is manual seeding of keywords that we search for on the website of our companies. So currently we are searching for 3 groups of companies. First group is called innovators. By our definition, they are firms that actively react to a COVID crisis. And this includes such keywords as continuing to operate as usual, continue to provide services, online delivery, and about 200 other keywords. Second group is informers. It's firms that do not show such a positive reaction on their websites. So they either just inform about COVID situation or say that they're closing. So keywords include examples like close our offices, close due to COVID-19, activities are cancelled, and so on. The third group, which we called inactive or undecided, is a group of companies where we did not find any COVID-related information at all. So they may remain silent for several reasons, which I would also tell a bit later. So as I said, the initial step is manual keywords selection and setting it into the concept detection algorithm. So the second stage is enhancing our initial set of keywords. So this can be done by various ways. We tried to use some dictionaries extension, but with no major luck. And the best options that work for us is using Google Trends to enhance the set of keywords. So on the right-hand side of the chart, you can see an example. For example, a Google Trends cluster of synonyms and related keywords for the word COVID. So you can see that Google provides relevant other user queries, which gives us broad cluster of all kind of language that's used by people for COVID-related topics. It's COVID cases, COVID updates, COVID news, and so on. So, and the last final step of the automated content analysis is using a machine learning model. So in comparison to some similar studies, we used unsupervised model, which is called latent replay allocation. So what is good with the model is that it doesn't require any pre-labeled data. So we just feed in our 3 groups of companies with determined keywords, and it automatically clusters all the websites found into 3 groups. So after that, we create time series for these indicators, and you can see examples of keywords for innovators group who show that they're actively working, that they're stay on business, and informers keywords that suggest that they're probably closing or waiting for some easing of restrictions. The next indicator that I would talk about is cloud indicator. So we use indicator of cloud technologies as a proxy for firm's innovation process. And I will tell you quickly how we construct this indicator. So every website that company has have some so-called domain name service metadata or DNS metadata. So domain name service is a register of company sites, pretty much like address register. So we have a company website, www.company.org, along with its physical address or IP address. Some of you may know, like 102.25 and so on. It's IP address of the server where a website is hosted. So what is important that this register of meta information has details about which company, which vendor does the company use to host their website. So what we do, we detect all list of domain service vendors that host websites for the companies. We cluster website hosting vendors into cloud vendors and non-cloud vendors. And based on which cloud vendor does the company use, we assign a cloud indicator to the company. So if some company uses cloud vendor, we imply that it uses some cloud technologies. So the last indicator that we constructed is technological hiring indicator. So the idea was to look at the labor hiring activity of the firms in our dataset ahead of the crisis in order to understand whether pre-crisis hiring determines the behavior of the firm during the crisis. So currently we construct indicators in 2 ways. First version of indicator uses occupation dimension. So we used occupations that are classified as techies by the relevant literature, as you can see on the slide. This is occupations related to R&D and ICT, like IT engineers, web designers, IT business analysts, and so on and so forth. Second way of indicators that we are currently constructing is based on skill dimension. So we used AI-related skills that are mentioned in companies' job postings. and we determine whether a company posts some jobs that include some AI or ICT related task content. So as you can see from the chart on the right,
5 minutes left.
Thank you. So as you may see on the chart, we observe increase on the share of ads requiring machine learning or AI tasks, and it's steadily growing over time. So the next very important stage that I would briefly go through is merging the Burning Glass Technologies data and FAME dataset. So the problem here is that two distinct datasets have no common fields except of the company name. And moreover, as data is manually entered into job postings, there are a lot of grammatical mistakes, misspellings in company names, and so on. So we use natural language processing techniques on the firm name in order to do so-called fuzzy matching, where you use some of the similarity metrics. You compare two different names from distinct data sources and decide whether they're similar enough in order to say that it's exactly the same companies. So initial exercise was really hard because the time for applying the string metrics was really unrealistic. You can see some crazy calculations in the slide. And in order to increase timing and precision, we applied some filtering methods. So you can see on the histogram that there are some surprisingly stable typos in the company's names, like misspellings, absence of relevant white spaces, some extra characters, and so on. So after removing these extra characters, we use pretty standard solutions that were existing many years. It's called blocking and neighborhood indexing technique. So idea is very simple. Instead of matching every company name from one data source with every name from another, we use so-called blocking. So blocks are defined as some specific subgroups of companies based on some similar characteristics. So as a blocking index, we used 5 first letters of company names. And after we put the company names from both websites into these blocks, sorted them, and applied 2 records moving windows, we were able to arrive at pairs of company names like AB, BC, CD, which these letters as imaginary company names, company variants of the same name as the company throughout different websites. So we normalized all same and different versions of the same company name into one version. And in this way, we arrive at our final data set with 130,000 of companies. So I would quickly go through our descriptives. So distribution of our resulting sample shows that there are several sectors that are overrepresented in our sample. For example, IT sector, construction, and retail. So you can see that blue bars are referring to our sample, which we call FAME, and red bars are coming from business population estimates for whole businesses. So our cloud indicator also seems to have similar patterns as the one constructed by ONS from e-commerce survey. So our sample is described on chart on the left. It has the same patterns. And as we can see, larger companies have higher propensity to adopt cloud technologies. And cloud usage is increasing every year with drastic increase starting from 2017, where UK were introduced to several major cloud providers. So our tech hiring indicator is also comparable with overall population of firms in Burning Glass data. So and we can see that around 20 to 25% of companies hire occupation defined as IT specialist, and this percentage is steadily growing over time. So now is the most interesting slide. On the left upper chart, you can see visualization of our resilience indicator. So I'd like to concentrate on green series for innovators group. These companies who tell that they're active, continue to work, deliver goods, or provide online services. Black vertical lines, as you can see, represent dates when lockdown measures were implemented, and green vertical lines show when restrictions were eased. We can see that after every lockdown, number of companies that signal activity decreases. On the other hand, when restrictions are eased, there is an uplift in the chart suggesting more activity from companies. Because there were no significant easings from November to January this year, we don't see significant uptrends in innovators group at the second part of the chart. But we believe as people and businesses wait for restrictions and easing throughout April and June this year, we would expect further increase that we would spot during the next months. So results firstly confirm procyclicality of innovation. So when there are restrictions from try to engage with activity innovation less. And which is interesting is that levels in our sample match to UK innovators survey. According to UK IS survey, there were about 40% of innovator active companies in 2018. So we're really close. And we see slightly decreasing trends over the years. So I think this can be related to generally decreasing online consumer demand over the current year. For example, if you can see on the right upper chart, according to Google Trends, the frequency of online queries, for example, we can see on the slide, online shopping query is really decreasing over the year. And currently it's close to pre-COVID level. So consumers really show less interest into online shopping activity and really want to go outside. On the bottom slide, you can see that innovator companies have higher turnover across all the years. And it was noting that innovator groups have had, stably higher turnover. So it seems that companies that have money really have higher propensity to innovate. So we have shown that our methodology for collecting data and mining shows some interesting and stable results and significant trends. So we are still in the process of refining several of our hypotheses. First, about explanatory power of our cloud computing and IT hiring indicators, additional validity checks for resilience measure, and other hypotheses that we are interested in is to what extent is the technological readiness important? What is the timing between start of some technological development and positive results? And what's the average success rate for the innovation in the UK market? And to what extent does the technological implementation is complementary with labor hiring? So our preliminary findings from regression suggest that IT specialist hiring indicator is positively correlated with being an innovator. Financial background also is positive and gives higher chances to be able to innovate. And it's interesting that currently cloud variable appears in our regressions to be negative. And possible and interesting explanation to that is that if company is highly innovative before COVID and really worked in the online sector long before, it has no need to post any updates because COVID did not pose any significant disruptions to their business. And there are a lot of cases that can highlight that. So the last slide, our conclusions. So we're still in the process of getting some results from regressions. And among interesting notes that I wanted to end with, I would like to note that the importance of current aim to dig into new and unexplored sources of timely data, because it's only way to enable some timely research and quick insight into quickly changing economic situations. And additionally, our thinking about government steps correlates with what government actually did. So we think that it's right to support and give some money for R&D grants for small and medium companies so they are able to innovate as well as big companies. So government currently, last year introduced that he will target innovation spending up to 20.7% of GDP. And last year, government introduced 1.5 billion loan and grant package for enterprises. So we agree with it, but we think that it was good to introduce it before the crisis, so we would recover faster. So our further work would include sector analysis of results as well as determining which timing between hiring, innovation, and success is really important in the UK. And among other questions of our interest is what are the skills that are complements to cloud technologies usage. So thank you so much for listening to me, and I'm really open for your questions.
Okay, thank you, Alexi. Let me to congratulate, because an impressive piece of work, still ongoing, but really valuable from the methodology. So for, I mean, the potential application that you the data you are building have. I would have a couple of questions, but I would see before if there are a question from the audience, but I do not see any. Yes, there is one. Yes, Richard Kneller, please, Richard. If...
Hi, Richard. Would you like to ask your question now?
Oh yeah, okay. Hi, Alexi. I had a couple of questions, just very quick questions. One was about the groups, the informers, innovator groups, and just to the extent to which those may overlap. So if you thought about universities, for example, we closed our offices and went online, and closed our offices would put us in one group, and go online would put us in another group, and just the extent to which you were, you know, what would you do in that situation? How would you classify?
Yeah, let me maybe quickly explain to this one. So it's really easy. When there are two groups of keywords identified, we obviously give a priority to an innovators group. So as you say, if you're closing but you're doing something online, we would map you to innovators group. So we're doing this kind of, we are weighting it if there are more keywords in innovators that we spot.
Yeah. Okay. Yes. Okay. And can I just ask about the cloud variable? Is it, so is that identifying firms that are using cloud to host their websites? You don't, I mean, are you then assuming that they then use cloud for other functions as well? Or can you capture that?
Yes, that's partially right. So it's totally right that we're just spotting the firms that use cloud hosting facilities. And right, we assume we partially assume that the company may want to use some other services. And as from the trends, we see that in majority they really do, because trends are really similar. But there is some cognitive thinking behind our decision to do this implication. So obviously, if I'm a very ICT unexperienced company, I would go just with the cheapest solution, because going to non-cloud vendor is really cheaper up to several times. So if I do not intend to use any cloud-related technologies, I would obviously choose the cheapest solution. Just go to one-and-one, GoDaddy, and some other just classical web hosting provider. But if I use AWS or Azure, for some of the reason, it implies my hidden intention to use something more advanced.
Okay, great. A really nice paper.
Thank you so much.
Okay, more question? Otherwise, I would go with mine. Basically, I would ask you, if possible, you could possibly elaborate a bit more about the fact that innovators seem to decrease after the third lockdown. Which explanation do you have in mind for this? I mean, is
right. So there are two explanations that we're currently using.
Yes, because there is a drop of 7-8%. I mean, so I was just wondering if they became inactive in the web, or I mean, do you think there is another explanation or something else?
Well, obviously, again, as a scientist, we would say that what we are measuring directly here is web activity. So we may or may not imply some further thinking about what is the reason that they did some update on their website. So currently, as for the web activity, I think it's definitely plausible that a general online activity in the UK is decreasing. So as I again refer to Google Trends analysis, it shows that user queries related to online facilities really declining drastically. And secondly, as you can see from the COVID time series indicator, that it drops down after some lockdown measures, then it goes up during some announcements. So obviously it's a very simple explanation to that. So when some companies anticipate that everything would open and so on, they want to signal to the market that, hey, we're also working. If you're consider I don't know, going to some walk, please consider our bike facilities, which are now open. So please rent a bike from us because we are open and we are now also working. And so this is second explanation. And third part of the explanation is that, and it's, I would say it's totally non-scientific, but it's my personal one. It's that I really see from a lot of companies that I know, that are really fed up with, with restrictions, and they really don't know what else to do, because majorly a lot of quick innovations that company wanted to try that tried during the first year. So there are some astonishing news that they can post saying, oh, hey, we're innovated something, we invented something totally great that solves COVID problem. So this interest, this innovation interest steadily goes down as I personally see it.
If you have tried to correlate these percentage or with some uncertainty measure, so just to know if the uncertainty of the business climate may push company to be more active or less active, or just to have an idea about this change the propensity to be active or not.
Yep, thank you. This is really great idea. Would you propose some exact measures that we might look at?
I lost you.
Yeah, sorry. Yeah.
Sorry, I lost you for a while.
Yeah, I was saying that thank you. It's really a great idea to include some exogenous factor, some market factors. And I was asking whether you can think about some examples of variables that you may suggest to look at.
Okay. I don't know, but okay. Sorry, I have trouble to follow you. I don't know if it's my connection or yours.
Is it now better? Do you hear me now?
Yes. I don't know if there are more questions from the audience. Okay, I would say that we can complete the session here.
Yep.
But
so
you're the chair, so you have the lead. Sorry.
Yes, thank you so much, everyone, for being with us and listening to amazing work of Francesca and some interesting results that we had with our team. So we hope to see you on coffee break session. If you will have any other questions in your mind, we can meet at coffee breakout room to discuss further. So thank you so much again for your attention.
Thank you.